Right, with the previous video, I explained about the first hop redundancy protocol, right? Gateway redundancy protocol. In here, I explain about Hsrp protocol. So now I am going to implement, I'm going to configure Hsrp with this simple network diagram to get idea how it is work and those things, right? So if I explain the diagram in here, so I have two ISP connection. Let's say this is connected with the ISP, also this router connected with the ISP, R1, R2, two routers, and this is my PC. PC has the 10.10 IP. Now R1 and R2 use the 10.1 and 10.2, two different physical IPs, two different IP for the physical interfaces, right? So now for this PC there should be a gateway, right? In that case, actually I am not going to use the 10.1 or 10.2. Instead of that, I am going to use the virtual IP. In here there is a virtual IP, there is a virtual router that has virtual IP, let's say that is 10.254, right? So I'm going to use the 10.254 as the gateway. In that case, if any failure happened to the R1, let's say that is the active router, right? That is the forwarding router, it's failed, no worry. Your traffic redirected to the R2, whatever the router, whatever the available router, right? That's the advantage of the protocol. But first of all, I need to check the connectivity, right? I need to check connectivity to 10.1. That connectivity is okay. Also connectivity with the 10.2. I'm checking connectivity with the two physical IPs. That also fine, right? So then this PC has the ARP table also. What are the physical address of two physical interface, and what are the MAC address, right? IP address and the MAC address related to the two routers, those information, that means layer 3 to layer 2 mapping available with the ARP table within your PC. That's fine, right? So now I am going to configure the Hsrp. When I configure the Hsrp, the first thing what I need to do, I need to go inside this router interface. Let's say now I am going to configure the R2. I go to the R2 gigabit Ethernet 00 interface, and I need to run the command, right? I need to define what is my virtual IP. The command is standby, and I need to define the group number. Let's say group number is 1. You can use any number in between 0 to 4095, right? Standby 1 IP, and you can define the IP. What is IP? 192.168.10.254. That's a gateway, virtual gateway IP, virtual IP of the virtual router that act as the gateway for your PC, right? So the thing is, I need to run same command with the R1 also. With the R1, I'm going inside the gig00 interface. That means the interface that we connect with our LAN network, and I'm configuring standby 1 IP 192.168.10.254, right? I use the same IP with the both. This is the only command. After I configuring this, right? So if I check the status of the protocol, if I check the status of the protocol, so I can see who is the standby router, who is the active router, who is the router that forwarding the traffic to the internet, that is we call active. So simply we can run the command show standby brief. It will give brief idea about this network. It's saying the group ID is 1, right? There is a priority value, I will explain it later, right? It say, so I am running this with the R1, it say R1 status is standby, right? This is the active router, standby one is local, that use the virtual IP, this one, right? Both routers. So now I am going to run same command with the R2, same command with the R2. So now if I run the command show standby brief, right, it's a Hsrp enable with this interface, group ID is 1, priority is same as earlier, that is 100, status is active, active one is local one, right? This is the standby IP, that means 10.1. So according to this configuration, what happen is, right, so this router become the active, right? This become the standby, right? That become the standby. That's the selection. This is active, this is standby. This one is the active, this is the standby. So based on the output, right, you can check those information with any router. This is the first router, R1. R1 say, right, standby one is local one, that means my router. The active one is 10.2, right? Both are using the same virtual IP 10.254, right? Now let's say, now this is my client, right? I will clear this information now, right? Let's say this is my client PC. Now my client need to ping with, need to check connectivity with virtual IP 192.168.10.254. Let's see what happened. That is success. That communication is success, right? Fine. Now 10.254, it is reachable. Now actually I need to know who is going to respond for this, right? For that I am enabling the debug command, right? Debug IP ICMP, that means show me all the ICMP packet within that's coming or going out from to this router, right? I enabled in the debugging, right? For the ICMP protocol, it will show all the ICMP packet real time. So debug IP ICMP, I enable debugging with both routers R1 and R2, right? So now again I'm going to do the same communication with the -T, right? So now my PC sending traffic to ICMP packet, ICMP request to 10.254. Who is responding? So this is the R1 router, no respond, no ICMP packet communication with that. But this one, you can see it's reply, it's sending reply, right? That means for this ICMP packet, right, when my PC say I need to check reachability with the 10.254, who is going to reply? Active router. That means let's say this PC say I need to access the internet, then PC IP address say my gateway IP should be 10.254, right? My gateway IP address should be 10.254. I will edit that information, 192.168.10.254. We check the reachability. In that case, actually what happened, your traffic sending to the internet using the active router, not the standby, right? That is using the active router. So the thing is, now we have problem, we have doubt. So how they select this as the active, how they select this as the standby, what is the concept behind that? The concept is this, right? So to select active router, to select active router, there is a election. In that election, it select the, by default it select the first criteria, it select highest priority value, highest priority. So now the condition is both are with the same priority value, right? Highest priority value, this is the default value, default priority is 100. If the priority is same, it's going to the second criteria, that is highest IP. It's compare these two IP and select this as the highest, so that become the active, that's the criteria. So let's say I need to configure anyhow, I don't like this setup, that mean what I need to do is, right, let's say my company has this ISP connection with 1 Gbps speed, this connection is only 512 Mbps, right? Let's say those are the two internet connectivity with the two different speeds. So then the idea is clear. Now what I need to do is, right, I need to configure this as the active, this as the standby, right? So simply what can I do is, default both routers, this interface come with the priority value 100. If I configure this interface priority value, let's say 150, then with the election it check what is the highest priority router, that is R1. So it will become the active, this become the standby. That means based on your requirement you can select who is the active, who is the standby. I will show that how to do that, right? So I clear those things, right? Now I am going to change this status. I need to configure this as active, this as standby, but current configuration is local router is the standby one, the active one is 10.2, right? That's the current situation. So what I need to do, go inside the interface, right? Standby 1 priority. So I can change priority in between 0 to 255. I configure this as the 150. Also for the re-election I need to run another command, that is standby 1 premeet. We need to run that command also. It always compare the highest priority and select the active one. Now you can see after that command, right, this router change the status into the active, right? Now if I run the command show standby brief, now you can see this router priority is 150, this is the active router, standby route is 10.2, but the earlier output is different, right? Earlier my status is standby when I have the priority value 100, right? When I change that to the 150, right, now my status is active, but earlier that is standby, right? Because of the highest priority, this will automatically become the active. Now we can check those things with this route also. Show standby brief. Now you can see this become the standby. Now who is going to reply for the gateway request? Let's do the same communication. So simply I am sending ICMP message to the 10.254. You can see now this router going to reply for that. That means now this act as the, this router act as the active router. It's going to forward traffic to the internet. That's the idea. So now let's say now what is the MAC address of this gateway, right? So I go to the PC and I am running simple command arp minus a, it will show me the layer 3 to layer 2 mapping. Layer 3 to layer 2 mapping mean IP address and MAC address information, right, within this PC. So it's a 10.254, that is my gateway. That gateway MAC address is this one. Actually, the thing is, remember, this is again virtual MAC address, not the real one. So this is the MAC address of virtual router. That means virtual gateway MAC address is this one, right? This MAC address not related to gig 00 interface or the gig 00 interface of the R2. Those are not actual MAC address. This is again virtual MAC address of Hsrp, right? So last 2 digit that represent what is the group ID. Let's say if you use the group ID 10, then last 2 digit of this MAC, say the group ID is 10, like that. So I can get those information with this route also. The command is show standby. When I run the show standby, it say my status is active, right? Then virtual IP is this one. This is the virtual MAC address, of this virtual IP. We have virtual IP and the virtual MAC. Actually, this virtual MAC address different based on the protocol, because previous session I mentioned 3 protocol: Hsrp, GLBP and the VRRP. This MAC address pattern change with different protocol. It's not same with the all the protocol, right? Then I need to show another important information, right? That is that has hello timer value and the hold down timer value, that is 3 second and the 10 second, right? So let's say now I will show this output also. Show standby. In that case, it say this is the standby router, right? Then you can see the priority value is 100. Previously both are with the 100, right? But I change R1 priority into the 150, then it become the active. Previously both are same. So this is the default priority 100. Then this is the local router. This is the standby router. Then it's no, this is the active router. Active router priority is 150. That has the same MAC address, virtual MAC address, that has the same hello timer and the hold down timer. So what's the meaning of that? Let's say how these 2 routers communicating each other. It's simple, right? Let's say now R1 is the active one. R1 act as the active one. The meaning of that, all the internet traffic sent to the internet via the R1. That's fine. So this is the standby one, right? So standby router should know this is available or not. This is available or not, right? So the protocol is FHRP, first hop redundancy protocol. First hop mean gateway redundancy protocol, right? So the purpose of the whole protocol is, if anything happened to this forwarding router, that mean active router, now this router should forward that traffic to the internet using that link. That's the idea. Then this R2 should know whether R1 is live or not, right? How it is known? There's a simple way, right? Every 3 seconds, it say hello, right? It say hello to the R1, and R1 also say hello, right? They are communicating with the hello message, right? But after 10 second, right, period, so now R1 looking for the hello message from the, sorry, R2 looking for the hello message for the from the active router, but it seems since last 10 seconds no hello message coming from the R1. then R2 assume R1 is not available, so I need to become the active. That's the idea. So standby router, always checking whether I receive the hello message from the active router. If I not receive hello message within 10 seconds, I assume that is not available. So my duty is I need to become the active and I need to send that traffic to the internet. Then this become the active. We'll simulate that also. So let's say first I delete the content. Now let's say, so I'm sending same traffic. I'm going to communicate with the gateway, right? So now you know this is the router who is replying, right? This one not replying for anything because this is standby router. Now what I am going to do, I'm going to simulate, let's say this is not available. So simply what can I do is I can remove the cable to simulate the router failure, right? Otherwise you can delete the router, that also fine. Now this PC feeling, right? So no, the thing is now I cannot access the internet, but after few seconds it's possible. How it is possible? Now you can see this router reply for the ICMP packet, because I will stop now it, right? So after few failure, again this client can access the internet, access the gateway without any issue, without changing anything. That's the advantage of the protocol. So let's see what happened within that. So see, after few seconds it detected R1 is not available, so standby router become the active one. Now this router going to handle the all the gateway traffic. So that's the way how protocol works, right? So in here, very important thing, in this concept there are two routers, one is active, one is a standby. Then how we select the active router with the priority? If the priority same, we can select that with the highest IP, then that use the virtual IP, right? That use the virtual IP. And I will show another important thing. I will again switch on this interface and let's see whether Hsrp traffic is available. So these are the Hsrp traffic, right? So what I need to show you is this routing protocol use the multicast IP. Hsrp use the multicast IP 224002. Remember that, that's very important. Hsrp use the multicast IP 224002 for their communication, right? So that is another important thing, right? So then thank you very much. I hope you get some idea about this gateway redundancy concept, right? This is only simple diagram, but when you are applying this technology to your real network, it's actually totally different story. In that case, we have layer 3 switches. With the layer 3 switches we have VLAN. We need to create VLAN interfaces and we need to enable this Hsrp protocol based on the VLAN, right? So thank you very much.